Okay, so good morning. We are going to start a new unit today on probability. And we see a lot of these probability examples, maybe with cards or rolling dice, or sometimes drawing marbles out of a bag. These are the most common times that we see probability show up on standardized tests. Just a quick little do now to get you, just a reminder, we finished up mean, median, mode, but we have a question here. Again, you can hit pause and read it, but I'll read it as well. Mr. Hartz's AP class, you received these scores on 4 tests. You have one more test to take, so there's going to be one more test to take, and you want your test average to be an 80. What score must you earn on your final test? So when I see these, I know I'm going to, for average, I'm going to have some values up here divided by a denominator, how many total values I have, and that's going to give me my average. In this case, we know what the average is, again, so that's going to be 80. We're going to have 5 tests because we already know scores for 4, but then we have this one more over here. So we're going to have a total of 5 tests, and then we know what 4 of them are. 80 plus 75 plus 88 plus 81 plus x. So once again, I did not make my chart big enough. Sorry about that. Equals 80. Okay, so this would be the setup. First step would be to multiply both sides by 5, so we get rid of this 5 down here, and we get 80 plus 75 plus 88 plus 81 plus x equals 400. That's, again, we're multiplying both sides by 5. To get rid of this denominator down here. And then we would add these all up and then subtract over, and we would get x equals this 400 that we had minus this huge sum, all of these together. We could probably do that quickly in our head. We got 80 plus 88 plus 81 would give us 249. That's the 380s plus the 9 plus 75. So we have the 400 minus 250 plus 75 would be 325. So we get 324. And this would give me 76. So we should get 76. And you can check that too. Okay, just a quick review. I only have 2 slides for probability, but the definition is a little bit tricky to kind of think about. But we have here our definition for probability, okay, over here. It says the chance that something will happen measured by the ratio of the favorable cases to the total number of cases possible. And so this is my kind of equation right here, my formula. And as you can see, it's a ratio or a fraction. And if you think about what a fraction is, the denominator is all the possible outcomes when we talk about probability. What's interesting here is you see a number line up here at the top. This goes from 0 to 1, and notice how it's kind of labeled. Something that's impossible would be probability. Something that's impossible would be 0. For example, the probability that an elephant would walk into this room right now and start to teach this lesson would be 0. But over here we've got probability 1. That's something that's certain. For example, the probability that if you have a drawer full of black socks and then only black socks, you'll reach in and grab a pair of black socks. And then something that's in the middle is what we call, you have obviously heard that term 50-50, so it's kind of a 0.5 probability. So that's what I really want to focus on today, is just the probability of an event happening is how many, my numerator is the chances of the event, and the denominator is all the possible outcomes. Okay? So I'm going to show you some more kind of definition stuff, and you can kind of hit pause and write this on your notes if you want. Just an example with flipping a coin and getting tails. And then let's just try a few, and then we'll move on to the next slide, and that'll be it. So let's look at Miss Smith. She's got 6 siblings: Matt, John, Mark, Paul, Mary, and Teresa. Mary and Teresa are twins. If she has to choose one sibling at random, so it's almost like they're in a separate room and she's just going to call out one of them, what is the probability that she will choose a boy? Remember, the way we would write this is the probability of a boy equals, we look back up at our definition, up here, right here, chances of it, like that's basically saying how many boys are there? Well, Matt, John, Mark, Paul are boys. How many total siblings, right? This would be my denominator. How many total siblings does she have? She has 6, right? And so that reduces to 2/3. So the probability of a boy is 2/3. Okay. What is the probability that she'll choose a girl? So the probability of a girl. Well, you saw up here, you saw up here that we've got Mary and Teresa. They're the only girls. So there's 2 girls out of a total of 6 siblings again. That hasn't changed. Notice my denominator didn't change. And that's 1/3. So the probability that she'll choose a girl at random is 1/3. What's the probability that she will choose a twin? Well, how many twins are there? Well, there's still 2 twins, right? Mary and Teresa up here. They are both twins, not just one of them. They're both twins. So there's 2 twins over a total of 6. You also get 1/3. So the probability of getting a twin is 1/3. That's an awful one, sorry. Probability that she will choose Paul. So I think it's useful to get in the habit of writing this probability of choosing Paul. Well, how many Pauls are there? There's 1. How many total siblings? 6. So I'll just kind of draw an arrow over there, shortcut that. What is the probability that she will not choose Mark? So these are the tricky ones, not choose Mark. So you can write it probability of not Mark. Well, how many, there's still just 6 siblings, how many of them are not Mark? You can go back up and look, or you can just remember there were only 1 Mark, which means there's 5 that are not Mark. So that one. And then lastly, what is the probability that she will choose George? Look up here. Do you see a George? Matt, John, Mark, Paul, Mary, Teresa? No. So the probability that she'll choose a George, there's no Georges. So that's going to be obviously 0. Okay, so that would be one example. Another example here would be looking at a piggy bank that's got 13 quarters, 20 dimes, 7 nickels, and 10 pennies. Whenever you have these probability questions, I think it's useful to actually find what the total is. So what is your denominator going to be? On the question above, we knew it was just 6 siblings. They told us. Here we have to actually figure out how many coins. So 13 plus 7, that's 20, plus this 20 is 40, plus 10. So I've got a total of 50 coins. So it might be helpful just to write that off to the side. I've got a total of 50 coins. So then probability of getting a nickel would be 7 nickels over 50. Can't reduce that. Probability that you'll choose a silver-colored coin. Well, quarters are silver, dimes are silver, nickels are silver, pennies are not. So we're going to add those. Probability of getting a silver is going to be 40 out of 50, which obviously reduce to 4/5. Probability that you will not choose a penny. Well, that's the same thing, right? How many non-pennies are there? It's all those silver coins. So probability of not penny equals 40 over 50. There's 40 non-pennies, 50 total coins. Equals is 4/5. And then lastly, you will choose a quarter or a dime. Now this is a different one. Or kind of means I win two ways. I like to tell students or means more. There's more ways to win. So I'm just going to raise this a little bit. How many quarters are there? There were 13 quarters. We got 13 of those and 20 of those. So the probability, and now I'll just use the first letter, of picking a quarter or a dime, I get both of these. So I get the quarters, 13, plus all my dimes, 20 over 50 equals 33 over 50. So that would go right here. Again, this is the key word, or. That means if I reach in there, I grab a quarter, I'm going to pull out a coin. If it's a quarter or a dime, I win. That's why I get to add. You will choose a quarter, dime, nickel, or penny. Well, here again, I see that keyword or, and all of these, quarter, dime, nickel, penny, that's all the coins I have. So the probability of getting a quarter, dime, a nickel, or a penny, that's all my coins. So there's a 100% chance that that's going to happen. That's all my 50 coins. I only have those same 50 in the bag. So 1. Lastly, I want you to look. What's nice about this one is that it does have colors. And again, we've got marbles in a bag. This is a very common one on standardized tests. 4 blue, 5 red, 1 green, and 2 black. You can also see them over here. 4 plus 5 is 9, 10, 11, 12. So I've got a total of 12 marbles. Okay, so I look over here. What's the probability of getting a black? There's 2 black over a total of 12. That's 1/6. Probability of getting a blue. I see 4 blue over 12. Remember to reduce. That's 1/3. Blue or black. So again, I get to add the blue. I've got 4 and black. That's 4 plus 2 over 12. That's 6 over 12. That's 1/2. Probability of not green. So here's my only green. How many of them are not green? Well, I've got the blue, the red, that's 9, and the black, 10, 11. So 11 over 12. So that's a pretty high probability that you will reach into that bag and not pull out a green. Not purple. We don't have any purple in there. So all of the marbles are not purple. And that's 1. Okay. So hopefully that's a good introduction to probability. Tomorrow we'll look at dependent and independent probability. Okay. Obviously, send me an email or send me a note in Schoology if you have any questions.